This is a pretty interesting question, I guess. So in this question, we're given a 1 by 2 rectangle and it's inscribed in a semicircle with the longer side on the diameter. And we want to find what is the area of the semicircle. So again, this is an example of where the AMCA they're not nice enough to give you a diagram. So if they don't give you a diagram and it's a geometry problem, then it's usually a good idea to draw a diagram. So we have a 1 by 2 rectangle and it's inscribed in a semicircle. So we're going to first draw a nice semicircle, right? Like that. And then a 1 by 2 rectangle is inscribed in it with the longer side on the diameter. So that means the rectangle, the side length 2 is going to be on the diameter. So you can draw the rectangle something like this. So 1 by 2, right? Where 2 represents like this length, right? So we want to find what is the area of the semicircle. Well, to find the area of the semicircle, we need to find the radius of the semicircle, because once we find the radius of the semicircle, we would just take a half pi r squared to get the area. So basically what we can do is we can focus on where the center of the semicircle is, right? So the center of the semicircle will be here. Like it's gonna be right at this like middle, like right at the midpoint of this side of the rectangle, right? So since this entire length is 2, then this center of the semicircle is going to divide this side length 2 into 2 side lengths of 1. So this is 1, this is 1. And if I were to draw this line from here to this point, notice this is clearly a radius of the semicircle. I would call it r, right? Because it's from the center to a point on the circumference of the semicircle. So now this is a right angle because, you know, in a rectangle, all 4 of the angles are right angles. So I can take a look at like this blue triangle, right? And I can apply the Pythagorean theorem to it. So I would say like 1 squared. So the sum of the squares of the legs, which is 1 squared plus 1 squared, has to equal the square of the hypotenuse, which is r squared. So then I can say, you know, 1 squared plus 1 squared is 2, and this has to equal r squared. So now we kind of know what the radius of the semicircle is. The radius is the square root of 2. But again, the question is asking for the area of the semicircle, but luckily that's pretty easy to get once we know the radius. So the area of a semicircle, the area of a whole circle would be pi r squared, right? That's like the formula for the area of a whole circle with radius r. But since we're dealing with a semicircle, we have to take 1/2 of that. We have to take half of that circle to get the semicircle. So we would take a half pi r squared, and we know r squared is 2, right? So in place of r squared, I'm going to write 2 instead. So the area is a half pi times 2, which is going to be pi. So the answer would just be choice C. And yeah, so the idea for this question is like a lot of the times for like harder geometry problems, it won't be like maybe immediately obvious what you should do. Like especially for more challenging geometry problems, you'll have to like draw something called auxiliary lines, which are lines that are not visible in the diagram, but drawing those lines will make the question solvable or like easier to solve. Like in this case, like the question didn't tell us to draw this radius, but when we drew the radius, like we can apply the Pythagorean theorem to that triangle, which allowed us to like solve the problem more easily.